Okay? I'm going to give you a couple of alternate forms and some locator points, and we'll be done with this one. Alternate forms of the equation look like this. Y minus k equals a times x minus h quantity cubed. The way we've been doing it would be y equals a times x minus h quantity cubed plus k. This would be the calculator one. Okay. So instead of calling that the
point slope,
vertex form of a quadratic, it's just a cubic type thing, but it's a perfect cube. Okay. Let's see. The other one that you'll see more often would be y equals ax cubed plus bx squared plus cx plus d. Okay. And what they do is a is always considered your leading coefficient. All right. And then they just do it alphabetically. Boom, 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 boom. Okay. So earlier when we were doing y equals mx plus b, we would do ax plus b. In some European countries they do that. They don't even consider m. They don't say m as slope. They just go with a because they deal with the leading coefficient business. And it just keeps everything similar instead of giving it a different name.
Yeah.
And it's not always 0 comma c that is your constant. It's whatever's last. In this case, or not constant. In this case your constant would be d. So your y-intercept would be at 0 comma d. Does that make sense as we go along there? All right, locator points. One of the most important points on this whole graph is at 0, 0. It is your inflection point. So you probably want to write that inflection point, even though it's already down there below. This, I would put these locator points, it's right below your graph there. And then if you have the form y equals parenthesis x minus h, a times x minus h quantity cubed plus k, then your locator point there would be hk.
Would 0 comma d be a locator point?
No.
Okay.
No.
And also, is there like something like the intercept form for cubic?
There is. It would be y equals a, but we don't normally use it. X minus p, x minus q, x minus r. That would probably do it. This would tell you the zeros where it crosses, right? So this is just written as a perfect cubed. Whereas when we were doing the other, we completed the square, rewrote the vertex form as a perfect square. But as you can see, there's no vertex on your cubic graph like there is on the quadratic. So it's not quite the same thing. We certainly wouldn't call this vertex form. Okay, perfect cube form, maybe.